Okay, today's lecture is on regular, normal distribution problems. Okay? The way you do these problems is always the same. So you're going to be given some situation or some setup, okay? If I just make up an example real quick, they might say something like, okay, the cost of tennis shoes is normally distributed, and the mean cost of tennis shoes is $50. Okay? So they give you some sort of normal distribution, they tell you the average, which is right in the middle, we know that. And they might say the standard deviation for the cost of tennis shoes is $5. Okay, so they've given me two things. They've given me the mean is 50. They've given me the standard deviation is 5. And they've told me it's a normal distribution. Okay, those three things are absolutely required. They have to say it's normal, they have to give you the mean, they have to give you the standard deviation. Okay, great. Then the question that they might ask is, you go buy a pair of shoes, a pair of tennis shoes. What's the probability that your tennis shoes were over $60? Okay, that might be the question. So somewhere out here, we have $60, and the question is over $60. So if I have to shade over $60, which way will I shade? To the right. Okay. So here's my question. I want to know the area of that little section. Okay? That's what the setup's going to look like. Well, your job is to transform this to a z standard normal distribution. So we're going to transform this to a z distribution. And in a standard normal distribution, what is my mean always? 0. And what's the standard deviation always? 1. Okay, which we've memorized from last class. All right. Then this 60 is going to come over to be some z value. And we're going to have the exact same picture. The reason why I have to do this is because this area, once I figure out what that z value is, I will be able to look up in my book. Okay? I don't have a chart in my book that has tennis shoes with 50 and 60. Okay? What I have is a 0 and 1 standard normal. So I take what I'm given and I convert it to a standard normal. Okay? So I have this situation. I want to figure out what z is. We use our z formula. It's your value, 60, minus the mean, in this case 50, divided by the standard deviation, which was 5. So I made it really nice. Really nice numbers here. 60 minus 50 is 10, and 10 over 5 is 2.00. Okay? So now the question becomes, find the area to the right of z equals 2.00, which we should be able to do in 10 seconds. Okay? I open up my book. I go to z equals 2.00. That will give me area to the left. I want area to the right, so I subtract 1 minus that. Okay? So go to your z chart. We go to 200, and what value do we have for area?
0.9772.
0.9772. So my area is going to be exactly 1 minus 0.9772. So grab your calculator.
0.0228. And that's it. So he's wrong. This one.
0228, yes. Okay. So the answer here, you buy a pair of tennis shoes, what's the probability it's over $60? Given this situation, your probability is 0.0228. Okay. Yeah, because the whole area adds up to 1. We got area to the left, and so we want area to the right.
So what was the question for this whole problem here?
The original question was, tennis shoes are normally distributed with a mean cost of 50. If you buy a pair of tennis shoes, what's the probability it's 60 or more? Or over $60? Okay, that's what we did. So, however the setup is, you guys need to draw the picture and then convert it to a z standard normal, answer that question, and then you can answer the original question. Yes?
So for the test, I have to memorize this whole chart?
No, you're going to be given the chart.
Okay.
Yeah.
Just make sure.
Yeah, no worries. Okay?
Yeah.
I can do it.
Yeah.
All right, let's try another example. So let's say, example 2, the average snowfall in Chicago is 50 inches per year with a standard deviation of 8.2 inches. Okay, the average snowfall in Chicago is 50 inches per year with a standard deviation of 8.2 inches. And somewhere in the problem, and at the homework usually does it right at the top, it'll say, assume it is normal, or assume this is normally distributed, okay? So somewhere in the problem it should say, assume it is normal. And then it'll say whatever it wants. Find the probability. It snows less than 35 inches this year. Okay? So why don't you guys take a minute, try to set this one up, draw the picture, draw where 50 is, draw where 35 is, draw the area that you're trying to establish, convert it to a Z standard normal, draw that picture, figure out that area, and then see if you can look up the answer in your book. Okay? This is what we call a regular normal distribution problem.
It's two decimal places for the z-score, right? Because that's what our chart says. Yeah, negative.
If the z is on the left, it's going to be what? Left of 0 would be negative, right? So you should expect a negative z-score for this. Okay, so on these z-values, because our chart only goes through 2 decimal places, let's round it to 2. So I'm getting roughly negative 1.83, because it's 2.9. So negative 1.83 will be my z-value. So now the whole problem becomes, from last class, find the area to the left of negative 1.83, okay? Find the area to the left of z equals negative 1.83. So you open up your chart. Negative 1.83 is 0.336. 0.336. So therefore my answer, because my chart is set up area to the left, it's 0.336, and that's it.
So if that number, if the inches was over 50, it would be on the other side of the mean, right?
If the 35 was like 85 or
Yeah.
something, yeah. Yeah, because this is in order, left to right.
And then that's why we drop it down to the left of 0 on the z.
Yeah, so if it was 85, it would be to the right of 0. Okay? Questions on this problem? All right, let's try another one. All right, the mean age of a CEO is, let's say, 56. And let's say the standard deviation is 5.93. Okay, and again, to do all these problems, somewhere in the problem it should say, assume the age of CEOs is normal, or assume it's normally distributed. Okay, I'm not gonna write it down to save some time, but it should say assume normal somewhere in the problem. All right?
What if it's not normal?
Then we won't be able to do it this way.
Oh.
Okay, but all of these problems will say normal. Okay. All right. Find the probability a randomly selected CEO is between 52 and 62. Okay? So let's all draw this one together. So we have the mean age is 56, and we know it's normal, so draw a normal picture. And the mean is 56, so that's going to be right in the middle. Okay? We're very, very concerned with what area we're trying to find. Okay? All of these problems, it's like, what area am I trying to find? In this question, the probability that a CEO is between 52 and 62. Okay? So where is 52? Somewhere here, maybe?
Sure.
And where is 62?
Yeah.
Somewhere here. So I need all of this area to get this problem right. Okay. Now, one thing that's a little bit different from this example is I'm going to have to transform 52 over to a z-value, but I'm also going to have to transform 62. So when you draw your standard normal, which you're about to do right now, you're going to have a z-value for this one and a z-value for this one. And the question is going to be, what's the probability, what's the area between those two z-values? Okay? Then you look it up in the book. So when we transform over, you need to do two z-value formulas. Okay, we have one over here, z, and one over here, z. Okay? So if I do the 52 one first, maybe I'll call that z1. You have 52 minus 56 divided by 5.93. That's going to be your z1. Then you also have to do z2. So z2 will be 62 minus 56 divided by 5.93. Okay? And again, these are z-values, so let's just go out 2 decimal places because our book only goes out 2 decimal places. So on my first value, I'm going to get 52 minus 56 divided by 5.93. If I round that up to 2 places, you get negative 0.67 for this one. And on the second one, I have 62 minus 56 divided by 5.93. And I'm going to get 1.01 for this one. Okay, so when I come over here, it's negative 0.67 and 1.01. And it's the area between those, okay? So now, after I've spent 5 minutes setting this up, now the problem is just like last lecture. Find the area between z equals negative 0.67 and z equals 1.01. Okay, and again, I told you last class, you have to be able to get any area that's asked. Okay? So the proper way to do this one, based on our table, is to look up 1.01, which gives me all the area to the left, then look up negative 0.67, and that gives that area, and subtract that area from the 101 area. Okay? So everybody look at 1.01 in your chart, and what do you get? 8483. I'm sorry, 8438. Does everybody see that? 8438. So all of this area from here all the way over is 8438. That's more than what I want. I just want from here to here. So now I need to subtract off this area. So look up negative 0.67. And that one is 0.2514. So finally, to get this answer, it's going to be 0.8438 minus 0.2514. And that will give me the area in between, which is what I want. So 0.8438 minus 0.2514. 5924. Okay? So based on this problem, the probability that a randomly selected CEO is between 52 and 62, the chances are 0.5924. Okay? so approximately 59%. Questions, sir?
Okay, so say one of the numbers was 0.6745,
Uh-huh.
and we're rounding it up. Would the 5 not round the 4? And then up to a 5? and
Just
then
go
a 5.
one place over.
Okay.
So 0.67 if it's a 4, just leave it. If it's a 5, round it back. Okay? And unfortunately, that's the best we can do with this table. So there's a little bit of round off error. Okay? All right, I want to do one more example. Notice in all of these problems, we were given z-values, then we were figuring out the area, and then we tried to find the area. Some of the problems go backwards. They give you a specific area, and then you need to go back and figure out the z-value, which will take you back to an x value. Okay, so let me do an example of that. But most of them are done this way. Okay, let's do an example where we go the opposite direction. Okay, let's say scores on a standardized test. Have a mean of 500 and a standard deviation of 120. I don't know. Okay. Mean of 500, standard deviation of 120. And again, somewhere it'll say normal. This test is normal. Assume normal. This test is normally distributed. Some sort of language like that. Okay. Okay, to qualify for a job, you need to score in the top 15% on this test. You need to score in the top 15% on this exam. Okay, and the question is, what score do you need to qualify? Okay, so this will be a good example of using the reverse. Okay, so let's look at some things. Let's take a look at the test. It has a mean, it's normal, and it has a mean of 500, right? We need to score top 15%. So can you show me where that score would be on this picture here? Where's the top 15% approximately?
Right.
Yeah, somewhere maybe my test score is right here. I'm trying to figure out that test score, okay? This area then would have to be what? 0.1500, okay, the top 15%. Is everybody okay with that? So I need to figure out this test score, okay? In all the previous problems, I gave you the score, and I was looking for area. But in this case, we're working backwards. We're doing area and trying to figure out the score. Okay, you're not going to be able to open up your book and find a z-chart or a normal chart with 500 in the mean and finding an x. Okay, what you have to go with is your standard normal chart. So I need a 0 and I need a z. 0.1500. Okay? So I need to be able to use my standard normal distribution chart, find 0.1500 in the right tail, and figure out the corresponding z-value that gives that. Okay? Now my chart only gives area to the left. So if the area to the right is 1500 and the whole thing adds up to 1, then what must this area over here be? Point what? 8500, right? Okay. So now let's go to the chart, but be careful. We're looking in the area portion of the chart. So look in the area portion of your chart and try to find the closest number you can to 8500. Okay, that's my job right now. I'm looking in the area portion, and I'm trying to find the closest thing I can to 8500. So it looks like I see 8485, and then I also see 8508. Does everybody see that? 0.8508. That's the closest thing I have to 0.8500 in my chart. Okay? So what z value gives me 0.8508? 1.04. Okay, does everybody see that? So again, you have to be amazingly good with these charts, right? 1.04. So this z value is 1.04 approximately. Okay? All right, here's where your algebra prerequisite comes in, right? So what is the formula? Z equals x minus mean over standard deviation.
Well, the 0.85 is the z equals 1.04, right?
This is the area that gives you, the z value that gives you an area is 1.04, yeah. Okay. So in all the problems previously, we were finding z. This time we have z and we're trying to find x. Okay, so now let's fill in what we know. Z is 1.04. We don't know x. We do know the mean, 500. And we do know the standard deviation, 120. Okay, so here's where you guys need to do a little algebra. All of algebra is solving for x. You guys need to solve for x, okay? So the best way to do this is multiply by 120 and then add 500, and that'll allow you to solve for x, okay? So x is going to equal 1.04 times 120, then plus 500. And that'll be the cutoff score that you need to qualify for this job. So let's see, 1.04 times 120 and plus 500, you get about 624.8. Did everybody get that? 624.8? So your answer is, to qualify for this job, you need to score at least a 624.8. Okay? So what score do you need to qualify? At least 624.8. Questions on that problem? So we did 3 examples going forward, and we did 1 example where you have to work your way backward. Okay? You have to be able to do both. Questions? All right.